People have been wondering for ages if we're the only ones out there in space. We've all thought about aliens, staring at stars and picturing life on other planets far, far away. Guess what? It might be real. The head of NASA just said that the James Webb Space Telescope found something amazing. This telescope is our best tool for checking out the universe. Get ready for a big announcement straight from the edge of our galaxy. They found life on a planet called Proxima b. This could change everything. Let's check out what the Webb telescope found and what finding life on Proxima b could mean for us and for going into space in the future. The James Webb Space Telescope is awesome modern tech. It can totally change how we see the universe. It's in space and super powerful, so scientists can see stars, galaxies, and planets better than ever before. It gives us a view of space we've never had. The telescope lives up to the hype. One thing that makes the Webb telescope so cool is its huge mirror 6.5 meters across. It's way bigger than the one on the Hubble Space Telescope, which has been super important for space research for 30 years. Because it's so big, it can catch even the dimmest light from far away places that other telescopes couldn't see before. Before, scientists could only guess what was out there, but now they can actually see it. Plus, the Webb telescope has awesome tools that can see different kinds of light. For example, there's the near-infrared camera, or NIR-cam. It takes pictures using infrared light. This is important because infrared light can go through dust clouds, which block visible light. So, scientists can see deeper into space. NIR-cam can also get really clear pictures, so astronomers can see how stars are made in galaxies up close. They want to study where the universe came from, the first light, how galaxies were born and grow, and find and study planets outside our solar system that we couldn't reach before. The Webb's tools, like NIR-cam, help us see how the universe is put together. They show us how galaxies form and change over time, and help us get a better idea of the stuff that shapes space. Another key tool on the Webb is the near-infrared spectrograph, or NIR-spec. It breaks light from faraway objects into different colors. This is called spectroscopy, and it gives scientists info about how hot something is, how fast it's moving, and what it's made of. NIR-spec helps scientists study stars and galaxies better. They can look at the colors in the light to find out what elements are there and how things are interacting. It also helps us understand how stars and galaxies live, from when they're born to when they die. One of the Webb's main jobs is to check out galaxies that are really far away. Their light has been traveling for billions of years to get here. By looking at the colors of the light from these galaxies, astronomers can figure out how old they are, what they're made of, and other important stuff. This helps them figure out how these galaxies changed over time. The mid-infrared instrument, or MIRI, is another tool that helps scientists study longer wavelengths of infrared light. It's good for looking at things like stars, planetary systems, and dusty areas where new stars are being born. MIRI also helps astronomers study the air around planets outside our solar system. This gives them info about what's in the air, how hot it is, and whether life could be there. The places where stars are born are really cool. These are thick clouds of dust and gas that block visible light, but infrared light can go through. Because of MIRI, scientists can watch stars and planetary systems being born. They can see what's happening inside these cosmic nurseries. MIRI is also important for finding planets outside our solar system. It can catch and study the faint infrared light from their air, which tells us about the planet's air, including the presence of water, carbon dioxide, and other stuff that could support life. When searching for life on other planets, the Webb telescope mainly uses spectroscopy and studies the air around the planets. Even if a planet doesn't have plants or oxygen, which aren't always needed to find life, these methods are still important. Spectroscopy, which is studying how light is soaked up or given off by something, is key for studying the air around exoplanets. When a planet passes in front of its star, the Webb can see starlight passing through the planet's air. This leaves chemical marks behind, which can be studied to figure out what's in the air. The Webb uses MIRI, which looks at mid-infrared light, and NIR-spec, which looks at near-infrared light, for this job. Together, these tools cover the range of light needed for a complete study. When starlight goes through a planet's air, it carries info about what the planet is made of. The Webb looks at these signals to figure out what the air is made of and spot molecules that might mean there's life or conditions that could support it. By finding different spectral markers, scientists can make models to understand the planet's air and climate. One of the Webb's main goals is to look for signs of life, like oxygen, methane, and water. But finding these things is only the first step. They need more observations to see if the planet is a place where life could live and if there are any signs of living things. Another important tool is comparative indicator spectroscopy, which the Webb uses to help find life. By comparing data from different planets, scientists can draw conclusions about whether life could be out there. What do you think about these cool discoveries? Leave a comment below, and if you liked the video, hit like and subscribe. See you next time. The James Webb Space Telescope can spot signs of life in the air around other planets. That's a big step in finding aliens. This telescope has unique tech that lets it see faraway planets in great detail. As scientists keep studying the data, they're learning new things about the possibility of life on other planets. The Webb telescope can see far back in time and watch the early stages of the universe. It catches light from galaxies that formed billions of years ago. This gives it a chance to study how the universe evolved. These observations give info on how stars, planets, and galaxies were born and developed, and the processes that shaped the universe. Besides searching for life, the James Webb Space Telescope is also helping us understand space in general. It can take detailed pictures of faraway galaxies, stars, and other space stuff. This helps scientists figure out the history of the universe. With each new discovery, the telescope keeps challenging what we thought we knew about space. It expands the possibilities for going into space and teaches us more about what's out there. As we look to the future, the Webb telescope will still be a key tool for exploring the unknown. The discoveries it makes could be a big deal, not just for understanding the universe, but also for exploring space. As we go further into space and look for life, the James Webb Space Telescope will lead the way. Basically, the James Webb Space Telescope is the start of something new in space exploration. It can see faraway galaxies, find planets, and look for signs of life. That's a huge deal in our search to understand the universe. With its powerful tools, the Webb is going to change how we study space and find out its secrets. The James Webb Space Telescope can study the air around planets the most exciting. It lets scientists search for subtle signs of life on other worlds. Its powerful tools let us see planets and their atmospheres with incredible clarity. By spotting key stuff that might mean life is there, like oxygen, methane, and water, the Webb helps us figure out if other planets could support life. It does more than just basic observations. The Webb's tech lets us make comparisons with Earth. Researchers can see how planets with similar features could support life. Through detailed spectroscopy, the telescope can break down light from stars and planets. It gives scientists a snapshot of the chemicals on these worlds. This is key for figuring out if exoplanets could be places where life could exist, and it opens new ways to explore habitable zones in the universe. The Webb can also focus on infrared light, which lets it spot hidden things like stars forming inside dust clouds or planetary systems developing. These areas where stars and planets are born are often hidden from view. But the Webb's infrared abilities let it see through this cosmic dust. It gives us a look at cosmic evolution. The recent discovery of life on Proxima b is just the start. As scientists keep studying the Webb's data and making more observations, we're about to experience something huge in space science. The telescope is starting a future where we might finally answer the question, are we alone in the universe? It also has great tools like the near-infrared camera or NICAM. It takes pictures using infrared light. This is important because infrared light can go through dust clouds that block regular light. So, we can see deeper into space. NICAM lets us watch stars being born in galaxies, up close. It's helping us learn about where the universe came from, how galaxies grew, and to find planets we couldn't reach before. The tools give us details about the structure of space. This helps us understand how galaxies are made and change over time. It also tells us what shapes the cosmos. Another tool is the near-infrared spectrograph or InSpec. It splits light from space into different colors. This is how we learn about temperature, speed, and what things are made of out there. InSpec helps us study stars and galaxies. It shows us what elements are there and how things interact. It also helps us understand how stars and galaxies live, grow, and die. One of the main things the telescope does is look at galaxies far away. The light from these galaxies has traveled for billions of years to reach us. Analyzing this light lets us figure out how old they are, what they're made of, and other important things. This helps us learn about how they change. The mid-infrared instrument, MIRI, is another key tool. It helps us study longer wavelengths of infrared light. This lets us look at things like stars, planetary systems, and dusty areas where stars are being born. MIRI also lets us check out the air around exoplanets. It gives us info about what's in the air, how hot it is, and if life could be there. The places where stars are born are very interesting. They're full of dust and gas that block regular light, but infrared light can get through. Thanks to MIRI, we can watch stars and planetary systems come to life. We can learn about what's happening inside these areas. MIRI is also important for finding exoplanets. It can catch and study the faint infrared light from their air. This tells us about their environment, like if there's water or other stuff that could support life. When looking for life on other planets, the telescope uses spectroscopy and checks the air. A planet might not have plants or oxygen, but these methods are still useful. Spectroscopy is when we study how light is absorbed or sent out by something. It's key to analyzing the air around exoplanets. When a planet passes in front of its star, the telescope can watch the starlight go through the planet's air. This leaves behind chemical marks that we can study to see what molecules are in the air. The telescope uses MIRI, which looks at mid-infrared light, and InSpec, which looks at near-infrared light, for this. Together, they cover the range of light we need for a good look. During a transit, the starlight going through a planet's air tells us what chemicals are on the planet. The telescope analyzes these signals to see what the air is made of. We look for molecules that might mean life is there or that life could be supported. By finding these markers, we can make models to understand the planet's air and climate. One main goal is to look for compounds linked to life, like oxygen, methane, and water. But finding these is only the first step. We need more observations to see if the planet is livable and if there are any signs of life. Another helpful tool is comparative indicator spectroscopy. The telescope uses this to help find life. By comparing info from different planets, we can make useful guesses about the chance of life out there. What do you think about all this? Leave a comment below. If you liked the video, please like and subscribe. See you next time. The telescope can spot signs of life in the air around other planets. This is a huge step in looking for life beyond Earth. The combo of technologies lets us see distant planets in great detail. As scientists study the data, they're learning new things about the chance of life on other worlds. The telescope can see far back in time. By catching light from galaxies that were made billions of years ago, it lets us study the start of the universe. These observations give us great info about the birth of stars, planets, and galaxies. They also tell us about the complex things that shape the universe. Besides looking for life, the telescope is helping us understand space better. It can take detailed pictures of galaxies, stars, and other things in space. This is helping scientists piece together the story of the universe. Each new thing it finds challenges what we thought we knew. It opens up new possibilities for space trips and teaches us about what's out there. As we look ahead, the telescope will be key to exploring the unknown. What it finds could change how we see the universe and the future of space travel. As we go further into space and keep looking for life, the telescope will no doubt lead the way. All in all, the telescope is a dawn in space exploration. It can see distant galaxies, find exoplanets, and look for life. This is a huge deal in our mission to understand the universe. With its tools and abilities, it will change how we study space and show us the secrets of the cosmos. The ability to check air around planets is great. It lets look for life on other worlds. The tools let us see planets and their air better than ever before. By finding compounds that might mean life is there, like oxygen, methane, and water, the telescope helps us guess if other planets could have life. It does more than just take pictures. The technology lets us compare planets to Earth. This lets researchers see how planets with similar traits could support life. Through spectroscopy, the telescope can break down light from stars and planets. This gives scientists a look at the chemicals on these worlds. This is key to guessing if exoplanets could have livable environments. It opens new ways to learn about habitable zones in the universe.